Hello, so I'm gonna try to test some propellers using a battery of 4 cells this time. This is the battery we're gonna use for testing. It has 2650 milliamp and it's when it's fully charged it would be 16.7 volts, and right now it's fully charged almost. But the problem, I think the ESC, which controls the speed of the motor, is not designed for this battery, I believe. So I'm not sure if it can handle it, because the current draw with full throttle would be way higher, I think, than what it can handle, which is 30 amp. I didn't even get to put it full throttle. I'm just worried that the ESC would... Yeah, the ESC kinda got a little warm, but still I wouldn't want to try full throttle, because I'm too worried about it. I think it already went way beyond the 30 amp, which the ESC can handle. We can see at mid throttle it was providing about a kilogram of thrust, which is super high. It's so hard to make a test without hitting something. I hate this shit. Okay, so it was pulling 40 amp and it was able to put 2 kilograms. That's quite a lot of thrust, I would say. We can test the other, the globe APC propeller, and see how much. They're exactly the same metrics, the same dimension and everything. This is the second one. It's called the Sport, APC Sport. I don't know if it is readable. The problem is the camera does not have the capability to focus properly. But this is basically a 12 by 6 inch. Come on, focus, focus. Yeah. So it's 12 by 6. It's the same size as the other one, except that this one is a little thicker. It's a sport version. which is really glow. It's very solid, very rigid, very stiff. The interesting thing is actually this electric does not consume as much power as the other one, because after all these tests we've only used 217 milliamp power, and so we're gonna try to see whether that will happen for this guy. And I think it's gonna consume way more. Which it's really quite strange that the motor didn't actually get too hot. Well, it did. The thing is that the propeller actually doesn't, there is no air going through the motor, because the propeller is pushing the air up and pushing down on the scale. It's designed to be not a pusher but rather a puller. Not the motor but more the propeller. Okay, let's test this one instead and see how that goes. Wow, wow! It was almost like it was for higher. So what it turned out is that the Sport actually is more efficient for higher current. Once you ask for more thrust, then you would go with that one. You'd go with the Sport, because then it seems like it would consume a little less, because it was able, but at a certain point actually it was able to pull the same thrust but at less current draw. And what happened is the Sport is actually was able to pull about 2 kilograms at only 27 amp, around that value. And instead for the electric propeller, it was actually pulling way less for much higher current for the same thrust of 2000 grams. It was pulling, it was drawing 40 amp of current. So that clearly shows that basically if you're looking for higher thrust and more efficiency, you would go with the sport. But as long as you're doing higher, as long as you're asking for high thrust, but if you're cruising at lower thrust, then you would go with the electric. The problem may lay in the vibrations, maybe because the propeller adapter, the one that connects the propeller to the motor, is a little bit not coaxial with the axis of the motor, and as a result there is quite a lot of vibrations. And maybe because the thicker one get less affected by those vibrations, so there is no slip, but the smaller one starts to have some slip between the air that is cutting through it, and that causes it to basically have less force. And this is mainly due to separation between the propeller surface and the air, causing turbulence and therefore less efficiency. So the solid blade is much better when there is vibrations, my guess. I don't know for sure, but that's kind of what I think. And that's my intuition. Regardless, thank you for watching, and see you next time.